flexible liners. So the individuals here are flexible liners, and we are told that we have two independent random samples, and the variable is their tensile strength in PSI, so it's a quantitative variable. We're just collecting a sample of fused and a sample of non-fused liners, so we just have an observational study, and we would just like to compare the mean strength for those two types of liners overall at the population level. So because we have two independent random samples, they are each representative of its own population. So on one hand, the population of all fused liners, and on the other hand, the population of all non-fused liners. And mu1 and mu2 are the mean of our variable tensile strength in each of those two populations. So therefore, when we have a confidence interval within this range here, this is where we expect that mu1 minus mu2 should be with 95% confidence, because the method used for computing the confidence interval has an overall success rate of 95% at capturing the intended parameters. That tells us that we are 95% confident that the difference between the mean tensile strength of all fused liners and all non-fused liners is somewhere within this range, possibly as extreme as negative 447 psi, or possibly as high as 37 psi. This is fundamentally inconclusive because mu1 minus mu2 could be negative. It means mu2 is greater than mu1, or mu1 minus mu2 could be positive, so mu1 could be greater than mu2, or mu1 minus mu2 could be 0, which means mu1 and mu2 would be equal, and that is why it is inconclusive. In terms of the conditions for inference, so again, we need two independent random samples for the two-sample T interval, and we do have that. We are told we have two independent random samples, and then we need either normal data or large enough combined sample size. So the combined sample size is not particularly high at just 18. However, we are told that tensile strengths are normally distributed. So yeah, the conditions for inference are met.